the answer, boys? Fadil? Fadil? Stress is equal to force upon area.
Yes, ma'am.
Now, what is okay? You just okay. Just tell me, Fadil, what is the value of the force?
100
So value.
kilonewton.
Okay, 100 by sorry, 100 into 10 to the power of 3. So it's a rod. It's almost the cross sectional area is pi r squared, right? Pi r squared. So just tell me, what should I substitute for pi? It's 3.514 into what is
Is it 10 raised to minus 4?
10 raised to minus 1? No, I think so. 10 into 10 to the power of, yesterday I made a mistake, 10 to the power of minus 2 the whole square. Correct?
Yes, ma'am.
Okay, then what should I do? Numerator becomes 10 to the power of, numerator becomes 10 to the power of 3 plus 2, 5, correct? Denominator becomes 10 to the power of 1 minus 4. So if I take 10 to the power of 5 and 10 to the power of plus 4 by 3.14. So that becomes 10 to the power of 9 divided by 33.14. Or if 3.14 is tough for you, so I can take this as 1000 into 10 to the power of 6 by 3.14. Or multiply by 100. Now I'm just doing my method. You can do by your 1000 into 10 to the power of 8 divided by 314. If I divide 1000 by 14, I think 3 times 12, 1, 3, 4, 9, right? Then it becomes 8, 9, 5, 1. So point. I go for 1580 means shall I go for 5? Is that somewhat 3.5 10 to the power of 8? Was just check with your answer. Yes, boys?
I'm getting 3.18.
18.
Is to 8.
Okay.
Yes, ma'am.
Is that 3
Yes,
point? 3.185. Now I need to find extension. The second part. So now I need to find the extension. How will I find the extension, boss? So extension is delta L, right? L is given as 1 meter. Young's modulus is given. So what is the formula? Y is equal to F by A divided by delta L by L. Can you find delta L from this? Stress is given. Stress is 3.18. That already you have calculated. Can you find? Rishit? 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 Muzamil, what will be the formula for now? What will be the expression for delta L? Muzamil?
I don't think Muzammil is there in the class. He's on a leave, medical leave.
Okay. Maheshwar, what will be the formula for delta L? Suppose if you need to. So I can write F is equal to F by A into L by delta L. So if I take delta L to the other side, it will be F upon A into L by Y. So delta L will be equal to, what is force upon area? 3.18?
And 1 10 raised to 8.
Oh, okay, 8. Okay, what is the length? Yes, boys, what is the length? 1 meter. The next one is 2 into 10 to the power of 11. Can you calculate this, boys? Delta L? Will you be able to calculate delta L?
Ma'am, is it 1.59 to 10 raised to minus 6?
Oh, 1 second. Shall I erase this? Okay. 1.59 10 to the power of minus 3 or minus 6, boss? Just check.
Ma'am, it's minus 3.
Minus
Okay,
3. Correct.
minus 3.
Okay,
Yes.
okay. You need not put this. This is not necessary. You can just put it as minus 3. Now, what will be the strain in the rod? Strain is, what is strain, boss? Delta L by L. So what is delta L?
Delta L is 1.59.
1.59. Okay, 59 10 to the power of minus 3 divided by the length is 1 meter. So strain will be 1.59 10 to the power of minus 3 meters. Is that fine, boys?
That's fine.
Shall I go for the next numerical? I think by this week we can finish this chapter. It's well and good. So only December first week we'll have a go. Shall I switch over, boys? Shall I switch over?
Yes, ma'am.
Next one. Textbook numerical, boys. All these are textbook numericals. The previous one, did you note? It's 9.1 of your textbook. Note down 9.1 of your textbook so that you need not write the question again. Just note down example 9.1 of your textbook. The next one is example 9.2 of your textbook. A copper wire of length 2.2 meter and a steel wire of length 1.6 meters, both of diameters 3 millimeters, are connected end to end. When stretched by a load, the extension is found to be 0.70 millimeter. Obtain the load applied. Load means what is the force applied. And boys, now this is the diagram. You have a copper wire. This copper wire has a length. So I can write the length of the copper wire LC as 2.2 meters, correct? Then the length of the steel wire, both the wires are attached together and both are having the same diameter. So the length of your steel wire, I'll write it as LS 1.6 meters. Now they are stretched by a load in that sense, a force. The net extension, so that net extension is, I can write this as the extension in the steel wire plus the extension delta LC. Delta LC is the extension in the copper wire. Delta LS is the extension in the steel wire. So both are found to be 0.7 millimeter. Clear, boys? And what is the diameter? Diameter is given as 3 millimeter, which is equal to 3 into 10 to the power of minus 3 meters. Now the question is, you have to find what is the load applied. Okay, boys. So we'll go for the general formula. Boys, we'll go for the general formula. First, can you write all these physical quantities, boys? Whatever is given. When you're solving a numerical, you should write what are the things given. Just have a rough diagram, then we'll go for the numerical. Is that clear? Ys is the Young's modulus of steel. Yc is the Young's modulus of your copper wire. 11b. Samuel,
Yes, ma'am.
Sanfat,
Yes, ma'am.
Anshul. Okay, fine.
Yes, ma'am, it's clear.
So write whatever is being given, then we'll see how can we solve this. See, both the wires are undergoing the same stress because the load is going to be the same. Both the wires have the same diameter. Both the wires are going to have the same diameter. So the force acting on them per unit area will be the same, which means the stress will be the same. So what is stress force? Suppose if I have a wire, right, the force which is going to act perpendicular to the surface per unit area, we call it as stress. So both the wires are connected together and both the wires have the same diameter, so that the force acting per unit area on these wires will be the same, which means the stress undergone by both the wires are the same. So now how will you equate? One second. First and foremost, we'll go for the formula for your Young's modulus. What is your Young's modulus? It is stress by strain. Now both the wires undergo the same stress because they are connected together and they have the same diameter. So the stress of both the wires will be equal to, but the strain will be different. Young's modulus is also different. The strain they undergo will be different. So now this will be the general formula. Stress is equal to your Young's modulus into strain. So now let us go for the stress acting on the copper wire and the stress acting on your steel wire. So both the stresses are equal. Now you need to solve. Is that clear, boys? Is that clear? Samuel,
Yes, ma'am. Yes, ma'am. It's clear.
Vishesh, Yusuf, Zuhair. So both the stresses are going to be the same. So now you have the right hand side, then you have to equate equation 1 and 2 because the stress undergone by the copper wire and the steel wire, the stress applied to copper and steel are the same. So left hand side of equation 1 and 2 are the same. So equate the right hand side, get Yc or Ys in terms of the other one. Are you clear, boys? You get Yc in terms of Ys. Let us see. What is that you are going to get? Kavin, Jonathan, Johan, Kavin,
Yes, ma'am.
Jonathan,
Yes, ma'am. This is Jonathan.
okay, Johan,
Yes,
Johan, fine. Now, sorry, Jonathan and Johan, both of you, just since I'll go for an empty slide. Just tell me, boys, what should I write? Let you dictate, I'll write. What are the two things that are to be equal? Johan and Jonathan, both of you. Left hand side of equation 1 and 2 are the same. So what is the right hand side? Johan, what will be on the right hand side, Johan? Is that Yc? Johan?
Hello, ma'am.
Okay. Johan, what will be the right hand side? Right hand side of the first equation. YC into strain. Correct?
YC into, yeah,
Strain. Okay. Strain is
delta LC
delta LC. Okay. Delta LC by LC.
by L.
That should be equal to for steel, right? YS into
YS into delta LS by
Mhm.
LS.
Correct. Good. Now let us find what is the value of LC and LS. The values are given. What is YC? What is the value of Young's modulus of copper? Did you write the value?
It's 110 to 10 raised to 9.
Okay, 110 10 to the power of plus 9 or minus 9?
Plus 9.
Okay, fine. Then I have delta LC. What is the value of the length of the copper wire, Johan? Copper wire has a length of
2.2.
okay, 2.2 meters, no? Correct? It's meters?
Yes, ma'am.
Okay, then fine. Then what is the Young's modulus of steel?
200 into 10 raised to power 9.
Correct, good. Okay, fine. So delta LS, what is the length of the steel wire? Even others
1.6.
1.6, that's in meters, fine. So what we'll do is this 10 to the power of 9 and 9 will get cancelled, right? These two things will get cancelled. This and this will get cancelled, correct? So what we can do is that we'll keep delta LC by delta LS. Okay. So what should go to the other side, Johan? 20 by 1.6 into. Tell me what should be the other side.
20 by 1.6 into delta.
2 point. This left hand side should go to the right hand by 11, correct? Correct?
Yes, ma'am. 2.2 by 11.
Okay, now calculate, boys. Now I think so you can calculate. This will be 0.2. Is that correct? Okay, what about this? Is this 0.8? No, it's 0.8.
Ma'am, I think 11 should be in the numerator and 20 should come in the denominator.
Okay. Here, boys, I'm taking it to the other side. No? Denominator will become numerator on the other side.
Okay, got it.
Okay. So now what will be the value? So 0.2 into 8. So delta LC by delta LS. Is that correct, boys? 20 by 8. So 10 and 5 and 2. So delta LC by delta LS is 2.5. What's the ratio? Are you getting 2.5, boys?
Yes, ma'am. 2.5.
Yes, ma'am.
Okay, okay. Then you have an expression, right, boys? Delta LC plus delta LS
Yes, ma'am. That's what I was about to
is
say.
equal to, what is that value? So here, what can you do is delta LC is 2.5 times delta LS. Can we go for that? Can we go for that, boys? Okay. In the initial thing, the total extension, what was the value of the total extension, boys? What is the value of total extension? Can someone tell me? Millimeters? 0.7? Millimeters, I'll convert it to meters, 0.7. No, 7 millimeters or 0.7 millimeters, boss.
0.7 millimeter.
Okay, then 10 to the power of minus 3. Now can you substitute for delta LC and get delta LS? Can you do this? First, substitute for delta LC in terms of delta LS. Can you get me the value of delta LS?
Ma'am, I got 2 into 10 raised to minus 4 meters.
20 into 10 to the power of minus 4 meters. Okay.
Ma'am, 2
Same
into
way, you
10
2
raised
into 10 to the minus 4. Okay. Can you check for the other one, delta LC also? Shamshul? Shamshul? Delta LS, you are getting it as 2 into 10 to the power of minus 4 meter. So delta LC is 5. Is that 5 into 10 to the power of minus 4 meter?
Yes, ma'am.
Okay. Now, what is the question? What was the question? The question was about force, right?
Find the load.
The load. So the load will be your. Have others copied? Have others copied? Copied the steps, boss.
1 second, ma'am.
Okay. Hitesh, Jatin. Jatin.
Yes, ma'am. This is 1 minute.
Okay. Okay. Boys, you have to be weekends, winter break. You have to learn properly, boys. You will not be able to manage your final examination. I'm telling you from the beginning. You have to be very serious about your work. So much of chapters, last minute learning will not help you. You will feel the pressure. So please keep learning. The first and foremost is listening in the class. Okay. Shall I go for the next one, boys? So what you have to find is, you have to find the load. Load means the force. Can someone take the screenshot and put it in the chat box so that I'll move for the next slide. Have you completed, boys? Because it's taking so much of time. Now the question is, you have to find the load means the force. So stress is equal to Young's modulus into strain. So what is stress? It is the force divided by area. The force is nothing but your load. So load is equal to area into this formula. Now you calculate, boys. Pi r square, r is the radius. So diameter is given as, I think so it was 3 millimeter. So find the radius. Diameter was 3 millimeter. Now you find the radius. Have you calculated? What's the value you are getting, boys? 11B.
I'm calculating, ma'am.
Okay. Is that 176.62 Newton?
Yes, ma'am.
I'll give you one more numerical as homework so that you can complete. Okay, I have a last period also. So if I can complete bulk modulus, then we have to do numericals on bulk modulus. Then what will be left is shear modulus and stress strain curve. So once that is over, this chapter, almost one application, this chapter gets over.
Ma'am, yesterday you said last period we will do last chapter's numericals.
Okay, fine. Whichever way, it's not a problem. Last chapter numericals. But shall I just give you, I don't know how many minutes left. Shall I, is that enough time for me to go for the next one? 9, 10, 10, 45. At least, you have any life skill period today? No. You have a life skill period today, boys?
Life
No,
skills.
not today.
No.
Just,
Ma'am, tomorrow first period we have live stream.
okay, fine, boys. Just to copy this, or will you do the calculation? If you know how to do, just do the calculation part. (176.62 Newton). So there is one more numerical. At least the diagram, can you take down the diagram, boys? 11B.
Okay, ma'am.
Which question number?
The previous one you want to check the value answer?
No,
Because
ma'am,
whatever the
question number.
question number, I just have to check the textbook first. And it's a textbook numerical. Just let me see what might be the question number. So just go through, just have a rough, just go for the diagram of this so that I'll complete this numerical and then I'll go for the previous chapter numerical. Just copy down this. So the question is, what is delta LS and what is delta LB? Extension of the steel as well as the brass wires. Have no need for writing all this because everything is being given over here. Only thing is that diameter is given as D is equal to 0.25 centimeter. You need not write the entire question. You can draw the diagram. You can write what is being checked, and only one addition is that your diameter of both the wires are 0.25 centimeter.
Ma'am,
Yes, boys.
our third period started.
Okay, you can leave, boys. You can leave.
Thank you, ma'am.
Thank you, boys.
Thank you, ma'am.
Thank you, ma'am.
Thank you.